All right. Hello, Professor. Good afternoon. This is Daniel's Boolean calculator. And first thing first, we have our prompt menu, just saying this is my Boolean calculator. And then we have our choices prompt. Our first choice is X and Y. Second choice, X or Y. Third choice, not X. Fourth, X or Y. Fifth choice, X is program. And then we have our uh, X prompt, which basically asks for the X value, and our Y prompt, which asks for the Y value. Then we have our error prompt, which displays error invalid input. Please try again. Then we have our hexadecimal prompt, which says this is the hexadecimal solution, and our solution prompt, which displays the solution. We have our solution prompt, which displays our solution in decimal. And then we have our Y value and our X value that are going to be inputted by our user. And then we have our case table. We have case one, two, three, four, and five. This is uh, all depending on what the user decides to pick. And again, it's and or not XOR exit. And then this formula kind of keeps interpreting our entries. Moving on, we have this call from Irvine, which clears the console so we won't have a mess going into our program. Then we have our menu selection. So we went to next line, but then we move EDX offset prompt menu, which displays uh, this up here. And then we call the string, so it displays the prompt menu. And we go on to the next line. Then we get our input here, which we call rechar, which reads the input from the user. AL is just what the user has entered. So we compared 5 to what the user has entered, and if it is more than 5, then we display our error message. And if it is less than 1, we compare the input to 1. And if it's less than 1, then we cycle through this. So it's just a loop. You go back up here. If it's more than 5, you get the error message. If it's less than 1, you get looped. Cost like process. And if there's a carry, jump quit. And I'll show you where quit is in a moment. Here we skip the line. We jump to menu. So this jump to menu kind of keeps asking you the same question. It's a bit of a loop. And then up until you hit exit, that's when the program stops. So here we have our error one section. So remember, if it's more than 5, we go to error one. And then we skip the line at first. And we have EDX as our error prompt. And then we call the error prompt and we skip the line and then we jump menu. So we just tell the user the error and then re-ask our menu prompt. Here our quit. If there's a carry, we would quit and quit goes to exit. Next, we end our main and we go to our select process and we push EBX onto stack, we push ECX onto stack, and then we point EBX to the table. And our ECX is entry numbers, so that being our X and Y. And then our um, EAX handles the user input. Yeah, so if we didn't have the entries, um, we would just skip over X and go straight to Y, and we don't want that. We want to know X and Y. And here, L1, we compare AL to EBX. Then we jump to L2 if not equal. Then we call So call near PCR EBX plus 1. If yes, call procedure. Then we jump to L3, which is our finish. Our L2 is we add EBX, so entry size into EBX, so increments and points to the next entry, and then we loop L1, which repeats until ECX equals 0. So we loop back up here until ECX is 0. And then here we pop ECX, which removes ECX value from stack. We pop EBX, which removes EBX value from stack, and then we return from the procedure. In our process, that's an end. Ends our select process. So process number 1, here we push AD, which pushes registers into one stack. Then we move EDX offset prompt X, which is asking for the X value. We uh, print the prompt, and then we read the decimal, which reads integer in decimal, and then we move EBX. We move EAX, which is the value inputted by our user, which is our X value, into EBX. Or EBX now holds our X value. And then we kind of do the same thing in prompt Y. We we ask for prompt Y, we print prompt Y, we read the decimal uh, inputted by the user, we skip the line, and now uh, EBX is held by X, and EAX is held by um, Y. So now we add EAX by EBX, and we have a result. So we move EDX off the result. We call our result display result, and then we display right decimal, display the result value to the console. Then we skip the line. So here we're gonna put next line. Okay, we skip the line, and we move. Uh, we call for our hexadecimal prompt, and we write our prompt. We write the hex value, and we get to the next line. And all right, after this process, I'm gonna stop and I'm gonna show you what I mean in the program. So pop AD restores registers, and then RET and procedure. So we're gonna have a side by side like that. So we said um, X is 0 and Y is 1. That gives us 0. So if we do it again and we have our X as 1 and our Y as 1, it shows us that if X is 1 and Y is 1, then the solution is 1. XY is 1, and the hexadecimal, it's 0, 0, 0, 0, 1. Okay, now for number 2. Procedure number 2. This ends our procedure 1. For procedure 2, we push registers into stack again. So I basically copied all this and pasted it over here. Same thing, same exact thing. We're asking for X, we're asking for Y. And then we are OR, which is OR EAX EBX. Remember, EBX holds the value X, and EAX holds the value Y. And then after that, we did the same thing up here. We copied all this for our result and our result in hexadecimal. We pasted it down here. So it's our results and our results in hexadecimal. And That's the end of our procedure two. We also copied this because we kind of need that. So we copied all this from procedure one. All we need is this as our difference. So back to my command prompt. So we go to procedure two. Our x value, we're gonna say our value is 0, and our y value is 1. So if our x value is 0 or our y value is 1, then it's gonna give us 1. And we can confirm this up here. 0, 1 is 1, 1, 0 is 1, 1, 1 is 1, 0, 0 is 0. So it can be either or. Yes, x or yes, y. So we have 1, 1. Oh, wait. 1, 1. We get 1. And our 1 in hexadecimal. Okay. Same thing for procedure number 3. We copied only the x prompt in this situation because it's just not x. So it's just not x, not x value. And we copied this same thing from procedure 1, result and hexadecimal. So so we only copied the x. Okay, let's start. In our procedure number 3, we only ask for the x value because we only need to not have an x value. So it's not x. In other words, we have our results, and then we have our results in hexadecimal, which we copied from procedure number 1. And then we have these registers from procedure. So if we go over here, we have number 3. So our x value is 0. If our x value is 0, then we get these f's. And if our x value is 1, we have these f's and this e. Now, to further explain this, I had to use this hex to binary converter. And then we have all these e's. So only looking at this, um, we see that the last one is 0. And then if we have an f, then the last one is 1. So it's still on off. So if it's 0, then we're gonna have all f's and our thing is on. So we'll have a basic. If we have not 0, we're gonna have a 1 up here. And if we have a 1, we're gonna have a 0 up here. I try to make it differently, but I can't figure that out. In our process number 4, we did the same thing in procedure 1. We copied all this, and then we pasted it here. Uh, asked for the S prompt, asked for the Y prompt. This is the only thing that was changed, which is X or EAX and EBX. And this is our X value, X or Y value. And remember, EBX codes X, EAX codes Y, because we pushed up here. We pushed EAX to EBX up here. So we can make room for our Y value. Next, we copied the same thing from procedure 1. So we we next we've done the same thing as procedure 1, in which we have our results prompt displayed and our hexadecimal prompt displayed with our decimal value and our hexadecimal value. Then we had these restore registers and restore procedure. In our process number 4, we exit from the program, and then STC sets the carry flag, and we return from the procedure. Then we exit our program, exit main, And that's it. That's the Boolean calculator. But just to show you over here in our command prompt, Daniel's Boolean calculator, we haven't done procedure 4. So for procedure 4, we enter our x value, which I'm going to say 1, our y value, which I'm going to say 0, and that gives us our hexadecimal answer and our decimal solution. So we check up here, XOR, uh, we have, we entered x as 1, and then uh, y as 0, and then we get 1. So that's how that works. And finally, we have our fifth choice, which is exit the program. And we are done. That's it. The program is now exited. No more debugging. And yeah, that's it for this assignment. Hope you enjoyed. Uh, have a good night.